Hello, Forecaster here, and I thought I should branch out a little bit. So today, we're going to take a look at liquid-cooled nuclear reactors from Industrial Craft 2. And before we do that, I should point out that this is recorded with Industrial Craft 2 2.2.737, which is an experimental build, so the things in this video are subject to change in the future, and most likely the values will be changed at some point. So let's start. Here we have the nuclear reactor, and if we open it up, we see we have 3 columns with 6 slots each, and this is where we can put our components and fuel. If we look at this icon here, you can see that this reactor is in EU mode. The output is limited to 50%. That means that this will only output 50% of the energy produced. You can also see it as this will produce 100%, and a liquid-fueled or liquid-cooled reactor will output 200%, or double the outputted energy. Now, in EU mode, we can put a cable next to the reactor, and it will connect, and the reactor will output energy directly. Also, to access these locked slots here, you have to add reactor chambers to your reactor. So we saw a column unlock. If I put another one, another column will unlock, and I can lock them again. And you can put 6 of these reactor chambers around your reactor, and they will also connect to cables, of course. So to get the maximum output from our reactor, we're going to want to build a liquid-cooled one. To do that, we need reactor pressure vessels, and they're crafted with stone and lead. And you want to build a 5x5x5 box with a reactor in the center, and you need to have all 6 reactor chambers on the reactor or will not work. Additionally, you're going to need an access hatch, a redstone port, and 3 fluid ports. So you're going to put the access hatch here, and already if we right click this, it will open the interface of the reactor, same thing as clicking it. And this is for accessing the reactor when it is enclosed in these blocks, as we can't click at the reactor directly. We want a redstone port. We put it here, and then we can close this side up. So the redstone port is where you input the redstone signal that tells the reactor to run. We're going to put a fluid port here, and this is going to be our output. To make it our output, we're going to need a fluid ejector upgrade. And if we read this, it says insert a fluid ejector to pump out hot coolant. So if we put a fluid ejector here, this fluid port will eject any hot coolant that is produced by the reactor into a tank or a pipe. In this case, it will be a pipe. Then we're going to go over to this side. We're going to put a fluid port here and here. And let's open the GUI, and let's open the interface. And now we can see that we have 2 tanks on the sides here. We have an input tank for cold fluid, coolant, and an output tank for hot coolant. We can also hover over this icon now, and we can see it's now in liquid cooling mode at 100% output, or twice what the normal reactor outputs. Now, you don't have to put these in these specific locations. You can put all of these special blocks anywhere on these 6 faces. You cannot put them around the edges or in the corners of the box. It seems a few components were destroyed for some reason while the reactor was off. Anyway, now we're going to need some coolant. To make coolant, you need a multi-purpose canning machine. Then you're going to need water or distilled water and lapis lazuli dust. You want the canning machine in fluid enrichment mode, and this is going to convert 1 bucket of water into 1 bucket of coolant. Now if you use regular water, it will use 8 piles of lapis dust per bucket. If you use distilled water, it will use 1 pile of dust per bucket. Then we're going to just connect this pipe to the fluid port, and the tank fills up with coolant. And this is going to be the return pipe where the cold fluid will return after being processed. So now we have coolant. Now I'm going to put a lever on the redstone port. You can of course use other things to supply redstone signal. I'm going to turn the reactor on. Now you can see the output in heat units here, and you can see it's taking coolant and it's outputting hot coolant here. It briefly sometimes get put into this tank here before being injected. You can also put cells in these slots. So you can put cells with coolant here and you will get empty cells back, or if the container returns something, you will get it back here. And you can put empty containers here to get them filled with hot coolant if you don't want to use pipes for some reason. Now we're going to take a look at how to process the hot coolant and turn it into energy. So, the simplest way to process hot coolant is the following. First, we're going to need a liquid heat exchanger, and as you can see, you can input hot coolant or lava. So we're going to put the heat exchanger here, and we have the hot coolant from the reactor coming up here, and it will be flowing into the heat exchanger. We want to rotate it by clicking the top face so the heat output is facing up. Now looking in here, we can see that it is filled with hot coolant. We're going to need heat conductors, and we're going to put them in these slots here. Now you need at least 2 of these, because with only 1, for some reason it doesn't do anything apparently, from what I've been able to tell. So you need at least 2, and for each additional one it's going to add 10 heat units per tick that it can extract, up to 100. So 2 is 20, and all this does is make it process the coolant faster. It doesn't increase the energy you get out of it. So you can just have 2 of these and it will work just fine, and you'll get just as much energy. But if you start to get a backlog, you may want to add a few more. So you can see that the element has turned red. Now if we're going to put a Stirling generator on top, and we're going to shift right click the top face to make it rotate downwards. And you can see this has started outputting heat into the Stirling generator, and the Stirling generator turns the heat into energy. So we're going to put an MFSU on top, and this is now producing energy. Now you can see the output tank has filled up, so we are going to need a fluid ejector upgrade. I'm going to shift right click this side because this is where we want it to output the coolant, and now we will see it running. And as you saw, after the tank had filled up, it had processed 1000 millibuckets, or a bucket of hot coolant, which had produced 10,000 EUs. So this is the simplest way to process the coolant. Now we're going to take a look at some other ways. So here we have a liquid heat exchanger again, and its output is phasing up into this steam generator. Now the steam generator takes in water and heat, and it will produce steam. Now these are the settings you need to produce normal steam. You need 1 millibucket per tick in input, that is input into the boiler, and we want 0 bars of pressure in this pressure valve. Now currently you can see it's outputting distilled water, and that is because there's no heat input currently. So it is sitting at just under 100 degrees, and it can't convert any of the water to steam. Now the steam generator is being fed with distilled water from this tank here, and you can use normal water as well, but if you do, there will be a buildup of residue in the pipes, which is called calcification, and this bar will slowly fill up, and once it reaches 100%, the pipes will be clogged and the steam generator will stop working. Now to clear the pipes and get rid of the junk, you need to disassemble the machine with a wrench and replace it, and that will clear the calcification and it will work once again. Now if you use distilled water, there is no impurities in the water which can build up in the pipes, so you will have no problems. You won't have to maintain this machine. Now the steam generator will output its whatever it's outputting to the closest block that accepts fluid. So this pipe is currently full of distilled water, so it's not accepting any fluids. So the water it's currently outputting is being put into this kinetic steam generator here. Now this has a turbine in it and a fluid ejector upgrade, which is outputting to the top. So currently the steam generator is being fed distilled water from this pipe. It is too cold to turn it into steam, so it's outputting the distilled water upwards into the steam generator, and the steam generator cannot use the water for anything, so it's just outputting it into this pipe and it's sent back into the tank. Now if we get rid of these and we grab some hot coolant cells and some empty cells for the output, and we put them in here, we can now see that the steam generator is outputting steam at 100 millibuckets per tick. So 1 millibucket of water becomes 100 millibuckets of steam. You can see the input is 100 heat units per tick. And this is outputting 200 kinetic units, which go into this kinetic generator, which is producing 50 EU per tick, approximately. And the steam is turned into water, which will be output into this pipe here. Now, when these are running, there is condensation that build up, and to get rid of that, you're going to need a condenser touching the steam generator. So this takes the excess steam and turns it into distilled water again and outputs it into this tank with an ejector upgrade. So, and if we remove this, this will start to explode, although actually not exploding. And this means that the excess steam is being destroyed, which means we're losing distilled water. Now I'm going to replace that. And this does not need power. However, you can put heat vents in here, which do require power, and that will allow this to work faster. And it does need the fluid ejector upgrade to output the water. Alternatively, you could pump out the water from it with a pipe, a fluid pipe. Now, unfortunately, this setup will produce less energy than this setup. Why have you stopped? You're just backlogged. Alright. So this produces 10,000 energy units per bucket of hot coolant. This produces almost that, but slightly less. So this setup is better than this one. However, you can go another step, and this steam generator is set up to produce superheated steam. And to do that, you need 221 bars of pressure. Now the wiki says 220. Unfortunately, that is wrong. You need 221, at least in this version, or it won't produce superheated steam. And 1 millibucket per tick in input, and the boiler will need to have heated up to 375 degrees. Now, superheated steam, when input into a kinetic steam generator, will produce twice as much kinetic energy than normal steam. It will also not have any condensation buildup, so it does not need a condenser. Additionally, so the kinetic energy will output into a kinetic generator like normal. Additionally, the superheated steam, when run through a kinetic steam generator, turns into normal steam, which this fluid ejector upgrade will eject upwards into an additional kinetic steam generator. So this will generate the same amount of energy as this one, and this will generate twice as much as that, approximately. And then this is outputting distilled water here, and the condenser keeps this from condensation from building up into this by removing excess steam and turning it into distilled water. So this setup will produce more energy than these two. Then this comes second, and this comes slightly in the last position, slightly after this one. Also, this needs 2 liquid heat exchangers as an input, because to produce superheated steam, you need to input 200 heat units per tick, and each liquid heat exchanger can only produce 100 heat units per tick. So you need 2 of them. Now, you don't need both running constantly while the boiler is heating up, but once it's reached 375 degrees, it's going to try to start producing superheated steam, and at that point you need a constant 200 heat units per tick input to maintain the steam production. And with that, it should be all you need to know to use the fluid-cooled nuclear reactors from Industrial Craft 2. So I will see you in the next video.